Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about SN10, serial number 10. So let's dive right into it. Now this is Starship serial number 10. This was launched on 3rd March 2021, 7 p.m. Eastern Standard Time. Now this puppy had 3 Raptor engine and the target was exactly same as SN9, 10 kilometers. Now it had 3 primary things to do. First, A, take flight. B, belly flop. C, land safely. Now the test was successful because it did a very clean takeoff. Everything was awesome, everything was fine. They had engine stable engine shutdown, no hoo-ha happened, everything was awesome. And then they did stable belly flop maneuver. Apparently at this point in time the belly flops is like completely done. They're like, we got this. Then they did something very interesting. 3 engine relight successfully. Now this was the main pain point for them. In the first one, when they tried to fire the engine destroyed itself. Second time the engine reignition failed. This time all 3 engines were lit and it worked successfully. And I do not mean they just caught on fire, they actually produced thrust. You can easily see marked diamonds there. So all 3 engines worked. Now benefit of that, A, it drained off the fuel very quickly, like it burned through the fuel engine very quickly, and it reduced speed a lot. And this gave them a very awesome advantage. It's like shut down 2 engines that are not performing well, as in comparison to each other. It's like one engine is behaving awesome, another is like meh. Okay, so they're like, okay, just shut down the meh one. So these 3 did their job, slowed down the system, and then one engine was like, all 3 engines are on fire. So they're like, okay, let's shut down 1, shut down 3, and then just relax with number 1. Just relax, just land. So this was quite successful. However, landing was a bit rough and it was on fire when it landed. Now everything was awesome at this point in time. It had landed, everybody is happy, everybody is cheering, and then after 8 minutes it went boom. So what the hell happened? Reality was it was actually on fire continuously during the engine shutdown period, from basically when they shut down the 2 remaining engines just to make sure that they do the final controlled landing. The rocket was on fire, and they did try, the methane was leaking at that point in time. They did try fire suppression system on the launch pad. If you watch the video continuously, the live stream, you will see fire delusion system. They are working full force, but it did not able to contain the did not able to successfully contain the fire, and fire finally broke through and it went boom. Now be mindful, because this area is not surrounded by buildings or some things that we can reference. This is a very huge structure. This boom event, even though it happened with a rocket with minimal fuel left, because again it burned through most of it, it was like running on fumes. When this happened, the fireball it created was huge. It created a shockwave, almost like, of course not as powerful as an actual weapons grade shockwave, but shockwave nonetheless. And I will urge you to watch the video down below. I provided the link down below. The person did an amazing job. Watch the fireball and then realize that these things are palm trees. You're talking about almost an airport size area going poof. It's huge, humongous, and I don't even want to think what will happen if ever this sort of thing happened on a fully fueled double stage system, basically stage 1 and stage 2. If it ever went to boom, the boom potential would be idiotically huge, and this gave us just a test of it. Like, think of this, like rocket has burned through most of it. There is no motion component on it, and it's just like residual fuel is this powerful. Like, that is like, we sometimes need to ground ourselves, like what kind of demons we are trying to deal with. This is huge. This is a building that is flying, and the boom it happened on a residual fuel was like a block leveling kind of boom event. So that is very humbling, so to say. Now what are the faults, like what triggered this sort of system? At this point in time, again, SpaceX is not gonna do full detailed analysis. They're gonna move forward and they're gonna fix the problem as they find. But as of now, all we know is that there was one engine that was acting a bit weird, and it has almost triggered what we call launch abort, and then they reset the computer so with extended guidelines, and then allowed to successfully take off. And you can see this in the video itself. And according to Scott Manley, one engine is burning way too much methane, like either it's getting overfed or something is happening. That's why the glow is not same color. Like all 3 engines are not glowing the same. 2 are doing the same, 1 is acting a bit strange. So this engine apparently is the engine that triggered the launch abort at the early stage. So one engine was acting up. Now landings should not have been this rough. This almost bounced. Now this does happen, even jumbo jets sometimes bounce, but it's very brutal on the aircraft. And if you have like 2-3 bounce on your jumbo jet, yeah, that jumbo jet may be scrapped, because they will do minor miniature fracture analysis, and they're like, yeah, structure is fractured to hell. So this should not have happened with this. Like, it should not bounce. Now, why the heck it bounced? Simply because landing leg failed. The video I have provided down below is quite amazing. You can easily see 3 legs done. They are ready, deployed, locked, awesome. Other 3, they are still swinging. They are not locked in the perfect, actual position. And the importance of this is that those legs have what we call crush core. Legs will be destroyed, but the shock wave will not go into the rocket itself. So inherently, think of this: so there are like 50% of your shock absorption was off. That is why when it landed, it did not have enough adequate quote unquote protection, because like 50% was like not able to lock. And you can easily see the rocket side is on fire at this point in time. It's like it's already on fire. Now, landing was too rough. Now, during this landing, of course, because of the shock that was created, it would have damaged something. Now, most current assumption while me making this video is that there was a valve that was leaking, but the shock over time is like, yep, ding, it completely made sure that it could not close properly. And because of the fire, slowly over time, it degraded something, and then it's like, boom. So that was the fault. Like, one engine kind of misbehaved. Landing was a bit too rough because landing lips flat out failed at 50% of the time. And so this was not a very gentle landing. Even on camera, it looks gentle simply because A, it's a building sized object. B, is the only one that has successfully landed. But you have to understand, as a landing go, like this is not a landing that you want to be in. So what we can expect in the future? Well, this provides a much more analysis that Raptors need a lot more development. Raptor is not in the same position as Merlin is. Like, Merlin is like, they know what they're doing. Merlin, go. Raptor is not in that stage, even though they are making a lot of it, and I'm pretty sure they soon they will be reaching 100th Raptor engine. They still need to refine that engine a lot. So engine, like, thankfully they are doing it, and because of their ludicrous speed, I'm pretty sure by next 50-60 engine they would be in a place where they're like, no, this is as reliable, as controllable, as definable as a Merlin system. But it will take time, so I'm pretty sure the engine needs a lot more work. Then the subsystems are failing way too often. For example, landing legs not locking up. That is kind of weird thing to fail. Now, be very mindful. The landing legs are not final design. This is just temporary. Even they know that this is not a final configuration. There's just like, do the testing, then we'll refine the legs afterwards. The design is not final. Now, this is common in rocket development. This was same thing was done with Saturn V. They were like developing other systems parallelly to each other before the whole rocket was finalized and designed. So this is common thing, but it does show that they still have room to grow. Like, they still have subsystem to solve. And this proves this is still the rocket science. Like, many times people say, like, oh, we're gonna use Starship for Earth to Earth travel. I'm like, A, physics is not stopping you. B, engineering is not stopping you. C, common sense is saying hell no. Why? Because it's equivalent of using a flamethrower to light a cigarette. Can you do that? Yes. Should you do that? Hell no. Think of it this way, like, that's the explosion that happened. Like, that should give you a context of it. What will happen if both of them went up? And if you're designing a port where you're gonna have hundreds of this, one of them will go boom. Sooner or later, one of them will go boom. Now, how much exclusion zone you have to create, and how you're gonna reach to that exclusion zone? So it's like really, really, and everybody's like, it's gonna do ballistic trajectory. Ballistic trajectory would be ludicrously painful or harmful or flat out lethal for humans. We are not ICBMs. It's like, yeah, G-force 50G 60G, we don't care. No, it's a plain system. If you want to release as a customer service, you don't get military trained pilot, or you do not get trained astronaut. You need normal average Joe. So normal average Joe would not like to ride into this, specifically if it's trying to aim that 30-minute launch window. It's like, yeah, take off from New York and land in Tokyo in 30 minutes. It's not worth it. And simply because the fuel cost, the amount of fuel it will consume, it's ludicrously wasteful. It's just like same as wireless energy. It's like, yeah, we will want to have wireless, and why the heck you want to burn the planet down? So this was the, like, that's why I'm saying, the watch the explosion. Like, realize those things, tiny things, are trees, because these things are happening in a kind of quote unquote vacuum. We don't get the scale of it. Oh, it's like it went boom. No, like, understand how big of that boom was. So there is a lot of room for development, and I'm pretty sure Raptor will need to go through a lot of design refinement where it's like, yeah, we got this, Raptor done. And subsystems, again, your landing legs should be deployed. So there's a lot of room to develop, but reality is this is rocket science. We are realizing that slowly. So this was my presentation on SN10. Hopefully you liked it, learned from it. In that case, please click the like button, share it amongst your friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.